Okay, guys, I'm going to repeat again the examples of the previous videos. We got the ideas about the applications of the normal manipulations of data using the IQ as our as our variable. So we have the means of the data is 100 and then the standard deviation is equal to 60. But now we want to estimate something, the area under curve within the 115 to 140. So the first one, we need to tabulate everything into the normal tabulations table. So this is the normal tabulation table. So based on the normal tabulation table, the locations of 115 to 140, something like this. Okay, the next one, we are going to estimate all these things if we compute into the Z tabulation data, which Z tabulation data is equal to standard normal tabulation curve. Standard normal tabulation curve is equal to something that we need to convert, which is the Z is equal to X minus the mean of the data divided by the standard deviations of the data. So we got 0.94 and 2.5 on that region. So we are going to estimate now the region of this thing. So how this thing is valid. So how this thing is emerged, or how this thing is being being projected, because this is 115 as a normal data. So 115 normal data is equal to 0.94. So 0.94 is our Z tabulation data. And then we got the another one will be the 2.5. 2.5 is actually 140 of the X data. So we got something to do with the 0.3264, and then we got something also goes to 0.4938. So if you can see here, the next rantau on the left is 2.5 is 0.49, and then the rantau on the left side of the Z is 0.4. So how you want to estimate something on this basis? You got something here 0.94 is equal to 0.3. You got here something on the 2.5 is equal to 0.4. So 0.4 minus the 0.3, we got 1.675. If you feel not comfortable with this, you can just imagine if you add. For example, if you add lah, if you tambah 0.4 with the 0.3, you got what? 0.7. So 0.7 is where? 0.7 is here. So is that logic? It's not logic. So the area under curve is 0.7 is not logic to be somewhere here. So this one actually is 0.5. So 0.7 indicate that the area under curve will be on the other side of the data. So it's not logic. So it's not right to make it plus. So the most appropriate one is actually you have this idea is 0.5. You got already is 0.5. So you must use the concept of which one is the highest. This one is the highest one, which is 2.5 is equal to 0.49. So 0.4938 is minus by the 0.3264. You got something to do with 0.167. 1674. 1674 will be converted into the 100 by times by 100. We got 16.74. So actually those who are fall within the 114, sorry, I'm mistaken. Sorry, 115, which is simulated by the 0.94 at the Z tabulation's normal standard, with the 140 at the Z tabulation normal standard, which is equal to 2.5. We got the region of there is equal to area under curve 0.1674, or equal to 16% of the total pupils inside those tabulation. So by using this, you can estimate those who are vulnerable, those who fall within this region, fall within these ideas, fall within these normal tabulations of data. So therefore, it's very useful for you to estimate something goes to the disease, something's related to the score, something related to the numbers that are really important for you to make a control mechanism and so on. Okay, this is the next examples. Okay, you got the tabulations of the IQ, and then you want to talk about the percentile. So now we are talking something about the different terms. We're talking about the percentiles. If you know, the percentile is about the 90th allocations of the data, or the 90th is what. So we got here the mean is 100, 116. 116 is actually the one standard deviations of the data. So lorekkan rantau adalah dibagi seperti berikut. So we got the 0.9. So 0.9 is actually something to do with the 90th percentile of the data. So this is the examples of the simulated figures. And then now we are going to use the Z-score to make sure it goes on the different directions. Okay, so how we got this 1.28. Okay, you must understand first. 0.9 here is actually indicate something to do with this thing, 0.9. Okay, 0.9 is actually our area under curve. So now nilai sepadan X dengan langkah 3. So actually, we are going to use the 0.5 as the indicator. So you must cut into the half, you know, you must cut into half. So actually 0.9 minus 0.5 is equal to 0.4. So now I'm going to find where is 0.4. So 0.4 here is not 0.4. So the real 0.4 will be here because this one is being bundarkan. We got the 0.4. So the 0.4 on the 0.399 3997 is actually 1.28. So 1.28, you put it back on the Z because we do not know the Z. So the issue here is actually the percentage of 90. We do not know the Z. So how we want to calculate the Z? We know already this one is 0.5. We do not know what is it. So we know already now this is equal to 0.9 minus 0.5. So we got 0.4. So the 0.4 is actually 1.28. 1.28 where? 1.28 here. 1.28 here, we just sum with our data here, which is our mean and also the standard deviation marker. Therefore, we got the ideas of 120.48. So 120.48 is actually 95th percentile of those who are getting the IQs, and then tenths of the everything is actually getting higher than this score. That's mean a majority of our data on the 90th percentiles indicate 120 score of the IQ, whereby another excess, which is 100 minus the 90%, which is 10%, is actually explained by those who are getting higher than 120.48. So I hope you can refer back to my explanation just now. So this trick is actually, we know already the percentile of the data, but we do not know where is the Z. We know already the Z location is there, but we do not know what is the value. So how you want to know the value of the Z? Of course, you know already the area under curve. You know already area under curve by looking into the question. The question already gives you the hint, which is the 90% of all them fall within the 90% of the 90 percentiles. So there is no 0.9 in our Z tabulation table. So of course, it's being cut into half. We got one of it is 0.5, and then another one of it is 0.5 minus 0.9 minus 0.5, we got 0.4. So the 0.4, the excess of it, that we do not know what is it. So based on the normal tabulation data tables we got for 1.28. So 1.28 now is our Z table. So if you look back, 1.28 is here. Is logic or not logic? Of course it's logic because this one is 0. See, this one is 0. This one perhaps is 1. So 1.28 is slightly on the right side of the hand, which is we got is equal to 0.4 area under curve. Sorry, it's not 0.4, 0.9 area under curve. Why? Because if we submitted everything including the 0.5, we got the 0.9. So the 0.9 is indicate something that to do with 90%. So then 90% is equal to 120 from 0.48 or 120 from these values. So you got the Z, and then after that you got the percentage. So this is the examples of the questions. I hope that you can pause this video, take a screenshot of this data, of these questions, and then try to answer it, and then we will discuss it into our class. Okay, make sure you do it. Okay, so I'm going to recall back the idea of the normal tabulation curve. So this is our curve. We can print screen also now. You already done it, right? Okay, good. So now we are going to the next one. We're going to the next question. So this is another question. I'm hiding my picture now so that you can make a print screen so that my picture are not disturbing you all in using these ideas to answer all the question. So you must make sure that you know about this thing, right? Okay. This one is 0.367 is from within the mean and the Z. So you must able to imagine. So this is the mean and the Z. So the Z you don't know, but we know it's the mean there. Sebelah kiri Z, which is on the left side of the Z. So we got the Z on the left side. Sebelah kanan is here. Antara is something in between, minus Z. Okay, antara Z and minus Z is actually something like this. Crossing it. And then from the next one of the tabulation of data, please identify the score for Z. So how you want to find the score of Z? Of course, you need to know that this is tabulations of 100%. So bahagi 5.5 score rendah daripada yang lain. So therefore, you need to imagine something like to do with the 90% of the percentiles just now. So divided 5.5, score is actually 94.5% of the data is higher. So the non-higher one will be the other side of it, right? Okay, you try to imagine it first. I'm not going to say anything because otherwise I give you the hint already. You try it first. Probably you can discuss with your friends. So this is another examples of the questions that perhaps you can answer it nicely. Okay, this is the area under curve, which is clearly indicate something for you so that you can refer it. So make sure you print screen of this video so that you got the ideas. Alright, this is the explanations of the normal tabulations of data. So this is the second decimal points in the placing of the Z. And that's all, ladies and gentlemen, it's finished. So I hope you learned something about the normal tabulations of data, how you want to calculate the area and the curve, and at the end of the day, how you can use all these things to estimate the percentage of the data which is tabulated 100% normally under area and the curve. So that's all, guys. I hope you learned something today, and don't forget to do your practices, and please don't forget to subscribe our channel. Bye bye.